In part 2 of this lesson, I'll show you 2 more examples on how to identify similar triangles. The first question reads, to determine the width of a river, Naomi finds a willow tree and a maple tree that are directly across from each other on opposite shores. Using a third tree on the shoreline, Naomi plants 2 stakes, A and B, and measures the distance as shown. Find the length of the river using the information that Naomi found. So we want to find out the distance from the maple to the willow tree. Let's start by showing that these 2 triangles are similar, and only if we can show that can we start to compare the sides. Now I know that the angle here and the angle here have to be the same because they're opposite angles. So I can write down that angle SBA is equal to angle WBM. That's one proof. Another thing that I can say is that this angle and this angle are the same. This is 90 and this is 90. So I'll write down angle BSA is equal to angle BMW, not the car. If 2 of the angles in the triangles are the same, then the third one has to be the same as well. Therefore, the triangle ABS is similar to triangle WBM. Now that we've proven that this triangle is similar to the other, we can begin to find out the distance from W to M. Let me erase this. What we have to do is compare corresponding sides. So this side from, let's say, B to M can be compared to side B to S. The length of B to M is 24 meters compared to 9.3. And similarly, we can compare the distance from M to W to the distance from S to A. M to W is unknown, which we'll write down as X, and the distance from here to here is 8.4. Now what we can do is make these 2 ratios equal to each other, where we have 24 over 9.3 is equal to X over 8.4. This is a simple cross multiplication problem. I'll cross multiply where 8.4 times 24 is equal to a number, and 9.3 times X is equal to 9.3X. Let's go ahead and find out what 8.4 times 24 is. That is 201.6. 201.6. To find out what X is, we divide both sides by 9.3. Divide this by 9.3. And now we know the distance from here to here, which is 21.6. 21.67 meters. Now if you want this to 2 significant figures, the answer would be 22. That's the answer to question number 1. Let's move on to question number 2. The question reads, what is the relationship between the area of each pair of similar figures? So we know that they're similar figures, and I'm going to start by finding out the area of the small one and the big one next. So the area of a triangle is base times height divided by 2. My base is 3 times my height divided by 2. That's 12 divided by 2, and that's 6. The height of this triangle is 6 times 8 divided by 2. That's 48 by 2, which is 24. That's a factor of 4. How about this one for the rectangle? We start with the small one, 2 times 3 is 6, and the big one is 8 times 12 is 96. And if you divide 96 by 6, you'll end up with 16. Therefore, the area of the larger rectangle is 16 times the area of the smaller rectangle, and the area of the larger triangle is 4 times the area of the smaller triangle. That answers question A, and in question B, they want us to find the scale factor, K. Since each side length of the larger triangle is 2 times the length of the corresponding side of the smaller triangle, as shown in the diagram, the scale factor is 2. And similarly, since each side of the larger rectangle is 4 times the length of the corresponding side of the smaller rectangle, the scale factor is 4. And we represent that as K is equal to 2 and K is equal to 4. Now we have to determine what the relationship between the area of the small, area of the large, and K is. Let's look at this carefully. The area of the large triangle was 24. If we take K which happened to be 2, and we squared it, and multiplied it by the area of the small, we would end up with 24. And similarly, if we took 96 and squared k, which happened to be 4, then multiplied it by the area of the small, 6, we would end up with 16 times 6. That's 96. So we can generally say that the relationships for similar figures is that the area of large is equal to k squared the area of small. And this is only the case with similar figures. There you have it. That is how to identify similar triangles.